So today's topic is about digital thread and digital transformation. How well is your digital initiative going? So what we're going to talk about today is why we think it's important and exciting to talk about digital technologies. What give some definitions of what a digital thread is, what digital transformation is, and some of the other correlating digital technologies that are of interest and important. We'll give some real world examples. So we'll talk a little bit about some, definitions are a lot of words. We're going to back up those definitions with some examples of where people in industry are using digital thread and other digital technologies or are planning on using it and making proposals. And finally, we'll talk about how an organization can get their head around how successful their digital initiatives are. So we'll start by setting the stage. Why is this an important topic to talk about? Why is digital technology important to talk about? But also, why is it important to talk about measurement in the context of digital technologies? We'll do some definitional stuff, talk about what is digital transformation, what's a digital thread. And then, as I said, we'll have some real world use cases followed by some ideas about measurements and metrics that an organization considering or in the middle of a digital transformation initiative might consider thinking about measuring so that they can have a better, they can wrap their head around or their hands around, I'm spending money on this. Is it bringing benefit? What's my return on investment? So at a 500,000 level, it's a communication framework that allows you to connect data, have data that flows from multiple systems. It allows organizations to view data throughout an entire life cycle. It's increasingly being used in industry and government to replace traditional silos, and it's got coverage through the system's entire life cycle and across many functional areas. Gartner did a study in 2021. More than 80% of CEOs plan to increase investment in digital transformation. IDC predicts that $6.8 billion will be invested in digital technology initiatives between 2020 and 2023. According to another study that Gartner did, almost half of all organizations who are involved in digital transformation have no metrics on their projects or the products within their systems. And many such organizations are finding it hard to understand what the return on investment is of their digital transformation spend. So they're spending a lot of money because it's not cheap. And they probably, a lot of them have some empirical evidence that this is a good thing. But, is the difference between what they're spending and what it's saving them? So measurement's an important aspect of understanding that. So what exactly is a digital thread? So I'll give you the wordy definition first from the Defense Acquisition University, DAU. A digital thread, it's an extensible, configurable, and component enterprise level analytic framework. It seamlessly expedites the controlled interplay of authoritative technical data, software, information, and knowledge in the enterprise data knowledge information systems. Basically, what digital thread does is it informs decision makers by providing capabilities to access, integrate, and transform disparate sets of data into something that's actionable. So it is a way that organizations connect multiple currently probably siloed systems that probably have a large amount of data duplication and integrate them in a way that the data is integrated and in a format that can be used across various platforms and software products. So it's also a permanent digital record of a product or a system's lifetime. So imagine a situation where a vehicle has a fault, and this causes an accident at some time post when the vehicle has been purchased. Having a digital thread creates traceability across the life of the vehicle. So this facilitates the organization that created the vehicle to quickly identify what the issue is, identify some possible proactive or reactive actions, and then address the issue. So some of the benefits of digital thread. So generally, when you employ digital technology, you're basing it in, at least in some parts, particularly in the manufacturing industry, which is where it's emerging most quickly. You involve model-based systems engineering or comparable tools, as you know, the design tool that feeds digitally information to the production line and other parts of the organization that require that information. This creates an environment for engineering excellence as well as manufacturing efficiencies. Because of the rapid way that one can modify their designs and pass on that information to all the systems that need it, it also creates an environment for innovation with both products and services, as well as optimization of services, because you have a permanent record, a complete record of the life cycle of a product. It also improves both the sales and the marketing experience. So a digital twin, this is a graphical proxy of a definition of a product or process which the real world is modeled against. So if it's a digital thread needs to be created, is required to enable one or more digital threads to enable a digital twin. So I'm going to once again give you the definition from DAU, and then I'll try to put it into, you know, a more easy to digest context. It's an integrated multi-physics, multi-scale probabilistic simulation of an as-built system enabled by a digital thread, enabled through sensors and input data, and it's used to predict activities and processes for the life of the physical twin. So if you look at the graphic on the slide, you'll see, you know, the thing in the air is the digital twin. And I like to describe this as basically a sandbox. So the digital twin is the place where engineers run simulations. If there's a problem, they figure out what the problem is via this digital environment and then are able to rapidly send a solution to the production line or the other systems that require a solution. So it's a sandbox. It's a place to figure stuff out, to run simulations. What if, you know, to optimize this system, we were to do X, Y, or Z? And the digital twin allows simulation to see which of those solutions are optimized. And the optimization could be, because part of your digital transformation might include, for example, you know, cost analysis, you know, design to cost kind of capabilities, as well as design to performance, design to how quickly something can be manufactured, you know, manufacturing efficiency. So I like to think of it as the sandbox where the engineers and the manufacturing and the design engineers have a place to figure out the best solutions to problems, the best enhancements, the best way to incorporate enhancements into the product. So the elements of a digital twin include the product. Obviously, this is what you're mirroring in the digital world, as well as the factory, because changes made at the product level from a design perspective need to be transmitted to the factory floor, so that you know, if processes need to change or if product features need to change, that is, you know, there's digital collaboration that makes that happen more rapidly. And then the digital twin provides the lifetime of information throughout the life cycle of the product or system. So digital transformation, I like to think of it as the reimagining of business in the digital age. And through digital technologies, organizations, they can improve their business processes, their organizational culture, the customer experience, which is going to result in improved productivity, quality, and improved service to the customers. The enablers for digital thread include interoperable data and technologies, digital twin as a foundation for improving manufacturing processes and sourcing. The digital thread, which connects to the digital twin with production information. So those are the enablers of a digital transformation. Its value is largely dependent on digital threads that connect all the aspects of the system, supporting rapid transfer of information and collaboration and rapid transfer of information, as well as the delivery of information to decision makers. So the digital thread is providing almost real-time access to data that's important to stakeholders, to decision makers, to people on the manufacturing floor, to the design engineers and the manufacturing engineers. To somewhat related aspects of digital transformation, not somewhat, these are related to digital transformation. Digital engineering, once again from DAU, digital engineering is an integrated digital approach. It uses authoritative sources of systems, data, and models, back to that model-based system engineering or model-based engineering, as a continuum across disciplines. It supports life cycle activities from concept through disposal. It's an enterprise approach for taking into account data-driven infrastructure methods, tools, and workforce transformation. And it's centered on authoritative source of trust. So a big aspect of digital engineering is ensuring and maintaining the integrity of the data that's in the system. So how an authoritative source of trust is established, well, what it is, it's an entity that applies, expert judgment and a set of rules to assert a digital artifact is valid and from a legitimate source. It should meet 4 conditions. It needs to come from a repository that's recognized by the governing entity, whatever that governing entity is, whether it's the organization, whether it's the government, whether it's some other institution. It needs to be considered to have integrity. So experts are called on to give opinions on credibility, accuracy, relevance, timeliness, and trustworthiness of the data. So basically, subject matter experts are called in and asked to help the organization or the project determine, is this data, can we call it authoritative? And can we trust it? And, it's a consensus of experts that's going to determine whether or not a digital artifact is authoritative. And the final enabler or condition for considering something an authoritative source of trust is assurances that the technical systems that maintain it maintain their integrity. So I'm going to talk through a couple digital thread use cases. My opinion, this is the most interesting part of the presentation because it is really cool what people are doing with digital transformation initiatives. So let's start with industry. Volvo Construction Equipment, a leading manufacturer of construction equipment. They have suffered from market pressure, both to shorten product life cycles as well as to increase product complexity. So this challenge has been compounded by siloed PLM, product lifecycle management systems, many manual efforts that are involved, as well as data duplication across systems. So they have lots of silos of data. There's duplication between those data. There are, efforts have to be taken manually to combine and assess what this data is telling them at a higher level. What does the integration of this data tell me? That's not something that's being done, was being done digitally. It was something that was being done by humans. Since 2018, they have replaced 3 of their 4 legacy PLM systems with Windchill, which is a single point PLM system. This has allowed the management of digital production definitions. So it's enabled them to take all that siloed data, all that duplicated data, and put it all in a consistent context where it can easily be accessed, integrated, and enable decision makers. So what's Volvo achieved with this effort? They've increased their collaboration across shared systems. So one of the things that one gets when one implements one of the things that one can potentially get if one implements a digital transformation is reuse of digital artifacts across systems. So the collaboration includes not just, person-to-person collaboration, but also system-to-system collaboration in ways that digital artifacts can be reused, because there's a global or organization-wide knowledge of what's out there, what's already been done. Lead time has been reduced, and just importantly, correct first solutions. So they got it right in earlier phases of product development than they used to. The benefit of this, which probably all of you people who are software project management people, the earlier that you get it right, the less expensive it is and the less rework needs to be done. And, the earlier you find a bug and fix it, the less expensive it is to fix. If you don't find your bugs until right before you go to production, or close to when you go to production, or even during your verification and validation time, it's way more expensive to fix than if you find it in early design. Increased reuse of existing artifacts. So this is going to reduce cost. It's going to reduce lead time, and it's going to increase productivity. And then this global governance to control the whole entire global product structure. So from an organization that has facilities all over the place, they all have access to this Windchill data, which makes it possible, like I said, for them to identify reuse, but also possible to share lessons learned and learn about multiple factories producing the same equipment. They get instant access to things that are learned in one factory or learned by one of their markets. So NASA, this is not a thing yet, but I thought it was too interesting an idea not to mention. They released a proposal recently to develop a high-performance spacesuit for the exploration of Mars, applying digital thread technology. So the vision is a digital human scan that's going to digitally design and analyze data about the human that it scans and send that to the robotic manufacturing system. So if you look at the picture, that the human is being scanned, and information about that scan is being sent digitally to the manufacturer of spacesuits. And it's probably a lot more complicated than that, but you get the idea. So what's this doing? What will this achieve if they successfully find someone to do it? The ability to rapidly design and manufacture extravehicular spacesuits that are aligned with individual anthropometrics. Basically, that means that the scan is able to detect, is this a male or a female, height, weight, how are we going to create a comfortable suit that is both comfortable and safe for space exploration. They create a digital twin. So the digital twin improves, it can improve based on lessons learned and design optimization. So when the first astronauts or people who walk on space or on Mars have used these suits, they'll be able to feed back information that then the digital twin can improve the design to maybe make it more comfortable, to maybe make it safer. Maybe lessons learned are, if I do this, the suit rips or whatever. Hopefully it wouldn't rip, but you get the idea that, if maybe there's some things that make it harder to use or less safe than it could be. So the digital twin can be used to rapidly update the design to improve the next spacesuit that gets produced. Ability for the crew in deep space to manufacture or repair components. So in deep space, in situ, as they like to say. It's also will create the ability to digitally incorporate the EVA, the extravehicular spacesuit, into the entire Mars mission architecture and the concept of operations. So this becomes a part of the whole big picture, but digital technology is allowing the suits to be customized, the suits to be updated, both based on lessons learned or to optimize design as more is learned in general about, walking on Mars. And some of the components can actually be updated right in deep space by the astronauts or the engineers that come with the astronauts, who are probably also engineers. Astronauts, I mean. Army. The Army has 2 future vehicle lift programs that are crucial to many of its current missions and many of its intended future missions or anticipated future missions. This is the U.S. Army. So a chief enabler of this is the application of digital thread. It ensures that the platforms are both combat ready. It does this through the integration of the mission equipment, the avionics systems, as well as the software that's required. So, as you all probably know, aircraft have lots and lots of software that do lots and lots of things. So this creates an environment that's going to integrate that, the stuff the software does, in addition to avionics, as well as with the mission equipment. So this makes it possible for capability improvements based on changes in technology, changes in the mission, lessons learned in the field. It also provides a tool set that helps reduce the uncertainty of, is this going to work the way we want it to work when we want it to work, as well as the addition of capabilities more quickly, as once again, as the mission changes, as the pilots learn more about it, as just the world environment changes are going to be needed. Changes are going to need to be made rapidly and rapidly and deployed rapidly. Digital thread solutions, they enable this, create this environment. Finally, this is industry once again, not government or federal. The Chile Group, and I might be saying that wrong. I apologize to the Chile Group if I am. They manufacture and service equipment that dispenses soft drinks, water, and beer. They have more than 100 employees, 6 production facilities, 3 are in Italy. It's an Italian company. 3 are in Italy and 3 are in the UK. They've implemented the Internet of Things an Internet of Things strategy that's going to connect end customers and help deliver services and increase revenue models. So what this initiative is giving them, it's increasing visibility. Increased visibility leads to more digital twins. So more systems are being ghosted, more sandboxes are being created, and this creates an environment where better simulations can be performed. They've also implemented a model-based system using PLM to facilitate this transformation as the foundation for this transformation, I guess is a better way. And what have they seen? What benefits have they seen? Their design cycle time has been shortened. They've advanced customer visibility at the point of sale and improved the uptime of dispensing equipment and controlling costs. So they've been able to get equipment out where it needs to be quicker. And they've been able, while doing this, to also control costs. Customer sales have increased, and the sell-through of existing inventory has also been increased. And finally, they're able to deliver customers fresher, colder, tastier beer or soft drinks, or probably not tastier, but fresher and colder water. So we're going to talk about metrics and measures now. Remember, one of the important points of this talk was to talk about how can we help organizations, how can organizations help themselves get their hands around what the cost, how the cost is justified, you know, what's making, how do we know that we're making things better? So measurement is important. Digital transformation and digital thread initiatives, they require a cost commitment. Organizations, they need to determine if the investment is bringing value and what their return on investment is. You know, they probably did some studies to figure out what it should be or what they expect it to be, but measurement is sort of put the rubber to the road and figure out, did what we expected to happen? Did it happen as quickly or quicker than we thought it would? Is it smart for us to invest in more digital transformation, or is it smart for us to back off? So some key measurement principles. Not every organization has the same goals with any initiative, but certainly with their digital initiatives. Not all organizations or projects have the same goals. And in fact, oftentimes organizations have a set of goals and projects may have a different set of goals. So it's important to have your measurement program driven by what are the most important things for your organization or your project. It's equally important to make sure that the measurement program measures things that are available. Seems like somewhat of a no-brainer, but it's silly to initiate a measurement program and say, we're going to measure X, Y, and Z when your technical and management infrastructures have no support for measuring X, Y, or Z. So it's important to measure the right things for your goals, but it's important to measure things that are actually there or that are easily added to your infrastructure. It's important not to select measurements that are just going to be time consuming and create lots of work when there are probably comparable measurements or at least available measurements that may lead you down down a different but as relevant path. SMEs within the organization and within the industry should help define what measurements are important, what metrics are important for a digital transformation initiative. Start small and be focused on what are the high risk areas in our project. You're not going to be able to measure everything, certainly not if you're starting off on a measurement initiative. So what are the 2 or 3 biggest risks of this not being successful? What can I measure that's available for me to measure. What can I measure that's going to throw up a red flag the earliest? So, all of those things are important. You have to pick the right measures, pick a small group to start with, focus on the ones that are going to provide the most value, the ones you perceive as providing the most value based on what you perceive to be the highest risks. And you want to make sure, and measurement over time, you always want to make sure that the measurements and metrics should be informing actionable decisions. So if you've been measuring something for 2 years and you go back and look, what exactly in our process or in our product or in our organization has changed because of this measurement, and you can't define anything or you can't find anything, then probably you should be measuring something else. So it's important. And there's a million different ways that people have categorized metrics or measurements in digital engineering, digital thread, digital transformation. So it's important to have a categorization. And the one that seemed to make the most sense to me as I was looking at this, and I've looked at multiple sources, and the ones I'm not providing comprehensive lists because there's an unlimited list of things that you might want to measure. I'm presenting ones that sort of rose to the top of, my experience and the research that I've done. So organizational metrics, ones that indicate how entrenched and adopted the digital initiative is in the organization. How widespread is it in the organization? Are people using it? Product or project. So what are the successes and the anomalies of digital thread efforts in a project or with the product? And process. How successful are the processes and methods that are incorporated or that are, part of the digital transformation initiative? So organizational metrics. Some things, obviously, the number of people that are using the models, it's important. If you're building these models, these digital artifacts, if nobody's using them, that's, you want to see the number of people using models and data and the authoritative sources of trust. You want to see that number going up. You want to look at maybe the number of people that are trained, and an interesting metric would be number of people using models versus number of people trained, and frequency of access. Once again, if 1,000 people use the model once a year, that's probably telling you that the models aren't very useful because they use them once and stop. If 1,000 people are using the models daily or weekly, then it looks like you're on a good track. So how many interfaces within your digital environment are there to the authoritative source of trust? How many people are using the digital artifacts that are created and maintained and monitored as part of your digital initiative? And then the number of interfaces. So how well connected are your systems to the authoritative source of trust? And how much consumption by users of digital artifacts from the authoritative source of trust? Also, how many people are going elsewhere outside of the digital environment to satisfy requirements that aren't part of your ASOT? Another thing that's important is adoption across the enterprise. So how many projects are taking advantage of the digital transformation, the digital artifacts? How many stakeholders are aware of and utilizing information that comes from these systems or these models? How often are the stakeholders using this to help them inform decisions? Important thing, and this is important thing across an organization, especially, it's also an important project thing, but the amount of reuse of digital artifacts. How much sort of bang for your buck are you getting as you create these digital artifacts? Are across the organization, are some of these digital artifacts being reused rather than back in the day of silos when everybody created their own way of collecting data, their own way of using data? How well is reuse being embraced by your organization? Support for automation, has it increased? Is it increasing within your organization over time? Do the people at the top, the people who sign the checks, the people who write the checks, are they highly supportive of automation and increasing automation? And then customer satisfaction. If your customer satisfaction is increasing as you transform digitally, that says good things about the happiness of your customers in ways about maybe how quickly they get the products, how quickly their products can be fixed if they break, and the quality of those products, how often they break. Some product metrics that I think are pretty important. Velocity. Is velocity increasing as you increase digital technology in your organization? Is the production volume increasing? Are things getting produced faster? Are your production processes improving, and is informing your production processes with digital artifacts in your thread helping to increase production volume? Obviously, when you're talking about a product, quality is important. You might call them defects, you might call them errors, you might call them anomalies, you might call them ECNs or change notices. It's really important if you're collecting defects, if defects or quality is important, which it probably is, it's really important to do it not just total defects, at the end of a release or whatever, but by phase, because as I mentioned earlier, the earlier defects are caught and fixed, the less expensive they are, the increase in productivity and the reduction in cost. So it's important to collect those both by phase and at a total level. Similarly, both cost and effort are important product metrics. And once again, it's important to collect these by phase and total as well. But by phase particularly because you want an understanding of how the balance between design and production is changing as you're automating your design processes and automating the design to production pipeline. It's important. Those are important things to understand. You would hope both the design time goes down and the production time goes down, but it's important to watch that and see if that is in fact the case, or if one is rising as the other reduces, and that would tell you something interesting about your situation that you might want to address. Size is a metric that we often use when we're trying to learn something about an initiative or a project or a product. It's a little unclear that what the right way to measure size is. Some things that have been suggested include the number of model elements. So, how many digital models have you created and are in use? More important, in use than created. Maybe the number of digital artifacts. That could also indicate the size. There are probably other things that would make sense. It would depend probably on the focus of your digital transformation and the things that are most important in that digital transformation with respect to increasing the increasing the footprint of that digital transformation or that initiative. Time, are you saving time? Are you getting things to market more quickly? Is your production line, are your productions increase the time from start to finish of production increasing? The time from start to finish of design, is that increasing? How many of the models have actually been reviewed? How How many successful releases? How many failed releases? Or the number of functions completed. So you're building a product and the product has, X number of functions that need to be delivered. How many of them have been completed at each release, and then at the end of the product deployment, at the time of the product deployment. And process metrics. Are you able to do V&V earlier and or more often? Are there increases in product automation? So is there a noticeable difference in the number of processes that have been automated due to the availability of digital technology? Have you created a sense of consistency in your processes? So as a process is used across maybe different teams in the organization, are they able to use it consistently? And are they, does the digital technology inform the consistency in the process? Are there increases in adaptability of your processes? Does the digital technology make it easier to make changes to the process as other systems identify the need for changes in those processes? How much rework has to be done? If you can decrease the amount of rework based on those things that you get correct earlier on, that is a sign of success of your digital transformation. Have you decreased cycle time? Looking at, and I talked about this a little bit before, looking at the percent of time spent on design versus the percent of time spent on production, that's going to give you, an interesting view. Are they both, are they decreasing at the same rate? Is, increased design leading to way less production? And, if they're not increasing, if neither of them is decreasing, that's a potential red flag. Once again, the product size per release would be an indication of how well your process is in producing consistent releases, if that's desirable. How many digital artifacts are created per release, or and maybe how many digital artifacts are consumed during the release? How much review data is being captured digitally? So how much review is manual versus how much review is, that there are digital systems that facilitate or absolutely take over the review. And the number or the percent of design engineering tasks that have been automated. So these are some things around your process that might be worth measuring and thinking about. So just to wrap up, first of all, thank you all for listening. I appreciate your time. I think that the digital transformation, the digital thread, digital twin, I think it's all really pretty exciting stuff. And I think that there are potential benefits, particularly in manufacturing, but in other areas as well. The integration of some of your maybe model-based software design tools into cost systems and integration systems and things like that. I do think that organizations that are considering digital initiatives should at the same time consider how they're going to determine whether or not their investments are being well spent, whether or not the digital initiative is giving them, you should start with goals, obviously, and you should determine the right measures, start small, that will facilitate understanding of whether or not you're reaching those goals. So at this point, I guess I turn it back over to you, Susan.
Arlene, thank you so much for your time.
Thank you.